We'll go over the two different ways to write the electron configuration, but don't worry, I'll go over everything step by step. Hello everyone, I'm Melissa Maribel, your personal tutor, and here's what you really need to know for electron configuration. Electron configuration helps us see how electrons are arranged in atomic orbitals for a specific element. There are four types of subshells: S, P, D, and F. The S subshell has one orbital that can hold up to 2 electrons. The P subshell has 3 orbitals that can hold up to 6 electrons. The D subshell has 5 orbitals that can hold up to 10 electrons, and the F subshell has 7 orbitals that can hold up to 14 electrons. The periodic table has all 4 types of subshells on it. We refer to it as a block. These first two groups are our S block, and helium is also part of the S block. On the opposite side is our P block. The inner transition metals are our D block, and finally at the bottom, we have our F block. Make sure you know these. This is the specific order that we follow for electron configuration, and yes, the order does matter. Let's do an example of an element in each block. Example 1, S block. To find the electron configuration of any element, we always start from hydrogen and make our way going from left to right to the element we are trying to find, which in this case is beryllium. So writing our electron configuration, since we start with the first row, hydrogen is 1s1, we move on to helium, which is 1s2, so we have 1s2. Next, we are on the second row, but still in the S block, so 2s1, 2, 2s2, and we stop since we reached the element we wanted. This is the electron configuration of beryllium. Example 2, P block. We'll find the electron configuration of sulfur by starting from hydrogen and making our way to sulfur. So 1s1, 2, 1s2 is the first part. Come back around onto the second row, 2s1, 2, 2s2 is the second part. Keep going straight across to the P block, 2p, 1, 2, 3, 4, 5, 6. 2p6 is next. Come back around onto the third row to 3s1, 2, so 3s2. Keep going straight across to the P block in row 3, and we will count up until we get to sulfur. So 3p, 1, 2, 3, 4, 3p4. This is our full electron configuration for sulfur. There is an abbreviated shorthand or condensed electron configuration that you will need to know how to find. Let's find it for sulfur. We always use the noble gas that is in the row before the element we are looking for. In this case, it's neon, and we place the noble gas in brackets. Think of the noble gas as a placeholder or the new place to start, so we will continue after neon and write the remaining parts of the electron configuration for sulfur. So 3s2 and 3p4. By placing our neon first, we are actually accounting for this entire portion of the full electron configuration, since that portion is the electron configuration of neon. Let's do another example. Example 3. D block. We'll find the electron configuration of iron by starting from hydrogen and making our way to iron. So 1s2, 2s2, keep going straight across to 2p6, come back around to 3s2, straight across to 3p6, come back around to the fourth row to 4s2. Now, we are in the D block, and the coefficient or number in front is always 1 less than the row it is in. So instead of 4D, this is actually 3D. And we will count up until we get to iron. So 3D, 1, 2, 3, 4, 5, 6, 3D, 6. This is our full electron configuration for iron. Now let's find the condensed electron configuration using the noble gas in the previous row, which is argon. We'll continue from argon to iron, so 4s2 and 3d6. And this is our condensed electron configuration. Example 4, F block. We'll find the electron configuration of plutonium by starting from hydrogen and making our way to plutonium. So 1s2, 2s2, Keep going straight across to 2p6, come back around to the 3s2, straight across to 3p6, come around to the fourth row to 4s2. Remember, the coefficient or number in front is always one number less than the row it is in for the D block. So we have 3d10. We're still in the fourth row, so 4p6, come around to the fifth row to 5s2. We're in the D block, so 4d10, still in the fifth row to 5p6, come around to the sixth row to 6s2, and we have a break in our periodic table. Your clue is the change in atomic numbers. We are now in the F block, which is at the bottom. Now the coefficient or number in front is always two numbers less than the row it is in for the F block. So instead of 6F, we will write 4F, and this is 4F14. Now we go back up to the D block. We know this because the atomic numbers have to go in order. Here we had an atomic number of 70, so next is 71. So 5d10. Continue to 6p6, come around to the seventh row to 7s2. There is a break in the table again to the F block, so 5f, 1, 2, 3, 4, 5, 6, 5f6. Here's the full electron configuration. Now let's find the condensed electron configuration using the noble gas that is before plutonium. So plutonium is at the bottom, but would have been in the seventh row, so we will use the noble gas in the sixth row, which is radon, and continue from there, so 7s2 and 5f6, and here's the condensed electron configuration. Now, if you would like help with your homework, online tutoring, or other helpful resources, I have all of that and more in the description box. And if you want to make sure you're ready for your next exam, I created a practice quiz video just for you with, of course, step-by-step answers. You can find that right here. And remember, stay determined. You can do this.